Hello everyone, welcome to this demo class for Pega Certified Data Scientist. In this demo we are going to cover the course structure of the data scientist and the exam pattern. And along with that we are going to have a two demo. One is based on the strategies that we create and where we apply the modeling tools, and another one is a Pega model. So we will be creating a predictive model in the Pega. So the agenda would be introduction, basically what this particular course is all about, what are the audience, prerequisites, if any, how the PCDS exam is actually structured, how this is conducted, what is the format of it, and then we will be having two demos. One is strategy demo and other one is model demo. That will be a predictive model. So about this course, so Pega Data Scientist course is particularly configured or actually institution for the people who actually want to explore data scientist area of the Pega. So basically this involves creating data modeling. So data modeling, we have Pega supports various type of data model, one being predictive, adaptive, and there are analytics of other kinds like text analytics and other stuff. All those will be part of the course. I'll just quickly walk you all through the course content that we will be covering during the course. So there is a concept called one-to-one customer engagement where Pega actually kind of targets each and every individual customers based on their property. So that's why it is called one-to-one. It's not that a group of customers are actually targeted for the marketing or for the decisioning purpose, but actually the particular customer and its attributes are actually used to derive a particular offer or propositions or whatever context we are using the strategy in. We will be covering the prediction studio overview. This is the main part where usually the data scientists work on. There they create and manage models. And then we will be covering the decision strategies where we use the predictive and adaptive and other stuffs. Other models in order to actually make informed predictions or adaptive modeling. Then we will be covering other areas of the decisioning where how to prioritize offers being selected for a particular customer. We will be covering predicting behavior, customer behavior using real-time data. We will also be demonstrating how adaptive learning is actually used in Pega. We will be looking at the impact of machine learning as well. And we will be building a predictive models. We will be looking at various aspects of it, like transparency and how we use it. We will also be looking at how we can use the models which are developed by a third party into Pega. So basically any model which has been developed into PMML modeling technology can be used, how we can import it, how we can use it into a Pega decision strategy. We will be looking at that as well. Then we have text analytics, where we will be looking at how we configure text analytics, how we do email routing based on that, how we do topic detection, how do we actually do sentiments analysis and all those categorization based on the text. We will be looking at that as well throughout the course. So this is an overview of the course outline that we have for the Pega Data Scientist program. Let me go back to this. Now, this PCDS exam is actually proctored by Pearson. So Pearson is a training company or the examination conducting company, which actually hosts various exams on various technology. So Pega has actually partnered with Pearson to host Pega Certified Data Scientist exam. The exam consists of 50 questions and it is actually carried out in 1 hour 30 minutes. The topics are, they ask questions on next best action, that is 8% of the exam. Decision strategies consist of 26%. predictive analytics consists of 22%, adaptive analytics consists of 34%, and text analytics consists of 10%. So this is how they actually configure the exam. These are the areas and the percentage of particular areas in the exam. Now we will be moving straight to the demo where we will be creating a strategy, and we will see how a strategy works in Pega, how we actually test it. That will be a basic strategy that is we are going to use just for the demo purpose. So before we actually get on to the strategies, I will just like to brief you about the strategy. So strategy is actually nothing but set of business rules that we execute in order to make a decision. So strategy is the brain of any marketing or decisioning project that we create in Pega. So let me just go through the Customer Decision Hub. So once you log on with the credentials which are appropriate for the Decisioning Hub, or the decision or the Marketing Hub, you will be landing on this portal. This is called Pega Decisioning Hub portal, or the Customer Decision Hub as now we call it now. So basically here you will see various menu options configured here: home, dashboard, next best action that will be covered into the course. There are contents related to the decisioning. There are intelligence related rules where we have prediction studio. On the prediction studio, we configure models and all those stuff. Strategies are also intelligence. So like I said, it is a brain of any Pega decisioning or marketing projects. Then there are various other rules that we configure, which are available here. We have audience segments, basically, on which we are going to execute. We actually execute our strategies in order to finally produce an offer. And then there are certain data which are related to the flows and the data management of the customer. These are the things that we can actually access from the Customer Decision Hub portal. So because we are going to have a demo on the strategy, so let me just go through the strategy. So all the strategies that you might have created till now will be listed here. Here there is one or two concepts that we need to know first before we actually start creating strategies. So there is one term called issue. Issue is basically what business problem we are going to solve. So when we create any strategy or anything related to offer, we actually have a particular issue in mind, and in that issue we have particular divisions or group as we call them in Pega. So when we talk about issues, so it could be related to maintenance, it could be related to sales, it could be related to enablement, or it could be, if it is a let's say a banking institution, right? It should be related to credit card sales. So sales, basically sales might have groups like credit card, loans, and all those stuff. So the issue there will be sales, and it could also be retention. We want to retain our customer. There too, we might have retention as an issue that we want to solve through this tool. And then the groups might be offering them discount, offering them additional packs, offering them goodwill gesture related offers. So this is how we configure, we actually organize any business problem into Pega. So those are divided into issues, and under issues we have groups. So for example, in the enablement, we have labels as a group. So this is something that I've already configured, on which we are going to actually have our strategy created for the demo purpose. All right, so let's create a strategy. So when we start creating a strategy, first we see a rule record where we need to specify what we are going to do. So in the enablement, we have just on the last screen we saw that enablement has a group called label. So in the enablement under label, we have actually printing cost and base cost related to the labels. Okay, so let's create a strategy where we are going to produce an offer to someone with the lowest total cost. Okay. So let's name this offer lowest cost. That will be the name of my strategy. Now this strategy is going to be applicable to the issue enablement and group labels. Here we will be discussing these things in detail, but at this point of time, let me tell you that this is something, the class where the strategy will be created. So basically it says that all the attributes, all the properties that the strategy is going to use, or all the data where strategy is going to operate on, where that data is defined. So in our demo purpose, we have everything defined in Pega CRM data customer. So that will be the class where we will be creating our strategy as well. Once we click on the create and open, there is a canvas we get, and we call it strategy canvas in Pega. So in the strategy, there is a result that is auto configured, and now we need to configure all those results. So like I said, strategy is the brain of any decisioning or marketing project. And through the strategy, we actually try to find out the best offer suitable to certain customer. So the question is, what do we call them offer? Those offer. How do we configure those offer? So in Pega, we have propositions. Propositions are the basically offers, static version of the offers. There are offers as well, which are applicable to marketing stuff. We will be covering that as well. So if you want to have a look what the propositions we have created before configuring the strategy, let's go back for a minute and see what are the propositions we have created. Now, like I said, everything in Pega decisioning is actually configured through the issues and group. So the issue, enablement, and the label is the group. Here we see all the properties which are added to this particular strategy, particular class label, which is actually nothing but the propositions that we have created. Let's see what are the propositions that we have at the moment. So we have labels. Under label, we have green label, back label, blue label. Let's quickly have a look on what are the fields that we have configured on this. So here you see there's a base cost, which is defined as 10, and there is letter count. Okay, letter count and base cost. This is something that we are going to use. There is also one flag or one property that holds true or false. This is actually to determine if the particular proposition is actually active or not. So in proposition, if we say that in the layman term, proposition is nothing but the offer or the things that we are going to deliver to the customer, or we are going to present to the customer. So this is how we have configured. We already have four propositions under labels, and we are going to use let's say 3 of them. Okay, and among 3 of them, we are going to actually present customer the offer which has the least cost, lowest cost. Let's go back to the strategy canvas. All right, so in the strategy, there are various ways. We will be discussing those in detail during the course. But in order to actually import the proposition, we need to first, okay, so we have created our strategy into the customer data class. So customer, all the property related to the customer is already available here to use. But the proposition that we just had a look is actually created in a different class, and that is a kind of data for the strategy. So the strategy will be using the customer properties, and then it will actually import the propositions, and then it will apply all the business logic that we will configure in this strategy to actually determine the best offer, the best proposition for the customer. So let's import the propositions first. All right, so because when we created this strategy, we defined enablement and labels already. So business issue is enablement and the group is labels. So it actually restricts us. We cannot change it now. Now the option is, do we want to import all the proposition defined under this issue and group, or do we want to import a few only, right? We don't want to import all. So let's import green label. And let's import a couple of more propositions. So green label is one that we already have imported. Let's import black label as well, and one more. green, black, and let's say red label. Right. So now we have imported all the propositions that we wanted to run our strategy on. All right. So let's go step by step. If I actually, okay, so in order to produce the result, the output has to be connected to the results. So let's connect all these to the results, and we will just check how it is working as of now before applying any further business logic. All right. So if we expand that right hand pane, we have and we save this strategy. So we can execute the strategy as well to see what kind of result it is producing at the moment, right? So if I run it, so we have already seen there were four propositions. Out of 4, we have included 3. So the result of this particular shape should have 3 results, right? So here you see there are 3 page results. One is for the red label, one is for the black label, and another one is for the green label. Like we imported all those. So we haven't applied any business logic. Whatever we imported, we are simply just putting that into the output or the result, right? So this is fine. Now, if we click on the individual shape, so it will give us the output of that particular shape as well. So if I click on the green label, it says it displays only one result, right? That is for the green label, because green label is data import, proposition import, where we have specified which particular proposition to import. So it is not going to have more than one results, right? Similarly, this one is also displaying just one black label, and the red label is also displaying one, right? Now, we have seen how we can actually import propositions into a strategy. Now it comes that how we are going to apply business logic into the strategy in order to refine that. So if you remember, at the beginning I said that we are going to calculate the total cost, and out of that total cost for all the propositions, we are going to select the proposition with the minimum cost. So in order to calculate the total cost, we need to actually look at what kind of cost we have already, what kind of information we have in the proposition, and how we want to derive the cost. So if you see at the proposition, for example, green or any label, because these are actually created in the labels group, so these will have the same properties. So there is a field called base cost, and then there is a field called letter count. Okay, so let's say that we are going to derive total cost as base cost plus, let's say that 5 into, or let's say 2 into letter count. Okay, so where do we store that? We need to create a one property to store the total cost, which is not already available. Any calculation that we do in Pega strategy, we have another shapes for that. One such step is called set property. So because we are going to set the value of the total cost based on whatever value we have imported through the proposition import, we are going to use this particular shape to calculate that. Now I'll have to join all those propositions. So the output of the proposition shape must be taken as an input of the set property, and here we are going to add one item. So if we already have a property defined, we can use that, but we don't have one. So what we will do, we will just create a total cost property. So in order to create that total cost property in Pega, we reference the property names through a dot. Okay, so all the property names start with the dot. So because this property is not, if it was there, we would have seen it. So in order to create that, we can simply click on this cross icon, and it will create a new property. Here we can configure what kind of property do we want and where do we want to create that, right? So enablement label, this is the class where we want to create that property. It must be related to the particular proposition groups. All right. So what kind of property do we need? Total cost is something that probably we need on numeric or maybe decimal, but numeric is not always going to be, because the way we actually discuss how we are going to create it, it is base cost plus 2 into number of letter. That might actually give us a decimal result. We can configure that data type here as well, or we can change that on the next screen as well. So let's create and open. So this is the property that we have created. If we want to, we can change it from here as well, but we don't really. So let's save it. Now we have a property called total cost to actually hold the value of the total cost that we need. Now, how do we want to create, how do we want to calculate the total cost? It could be related to a very simple, we can simply just copy from one value to other value, but no, this in our case, we want to apply a mathematical logic, right? So we are going to click on the crosshair and we are going to build an expression. So it should be base cost plus letter count into, let's say 2. We can test it as well. So if we click on the test and let's say that we say base cost is 10 and letter count is, let's say 20. So the result would be 50, right? So 20 into 2 plus 10. So this seems to be fine. Let's submit this and submit this. All right, and let's see now if the cost is getting populated properly or not. Right. So we just simply attach that set property output to the result and we run it again. Before we make any changes, we will have to check out the rule and then save it. We will be discussing what checkout, check-in and all other stuff means during the course. Now I have already saved it, so I can actually execute. All right, so green label, if I click on the individual shapes, we see, like I discussed already, the output of that particular shape. All of these 3 are actually producing 1. So that's why we see 1 page. Now set property actually is operating on the output of 3 different shapes, which are producing 3 different results. So it has actually 3 pages. Let's see the value that we just set. So that was total cost. See here. So for the first page, for example, a red label, the total cost derived is 46. Let's just quickly verify that. Okay, so base cost is 30. So 30 plus 8 into 2. So 16 plus 30 is 46. Perfect. Now let's see this other pages. Black label. It has base cost 20 and 10. So 10 into 2, 20, 20 plus 20 equal to 40. Right. So far it has been running fine. Right. So we have actually calculated the total cost. Now we want our customers to receive the offer or the proposition with the lowest cost. For that, there are other shapes available, one in the category of arbitration, which is called prioritize. So we are basically going to prioritize the set of offers produced so far based on the total cost. So let's just use this shape. And the input to this shape will be the output of the property set. Okay. Now, here we build expression. So because we already have calculated the property, the total cost into a property, which is total cost, right? This one. Now we want to prioritize the value. We can sort alphabetically as well if our output property is actually of that kind. So this actually depends on the use case here. Because we have a decimal property, we will prioritize on the value. how do we want to see highest first? So basically, if you want to output the offer with the highest cost, so basically ascending and descending order, we can use this one for the descending order, and we can use this one for the ascending order. So because we want the lowest first, right? We want them to produce the, we want them to see the, or the get the least expensive offer. Now, how much? We want them to give just one, the lowest cost one, right? So top one. We have configured this, and we have already mapped output of this shape to the input of the result shape. Let's save it and run again. All right, so now you see the result. The result shape has only one output, and this is for the one which has total cost as 30. So this green label, it has base cost 10 and later count 10. So 10 into 2 equal to 20. 20 plus 10 is 30. So that's the lowest cost. But the prioritized shape also has produced one, because we have actually limit. We have put a limit that, okay, yeah, produce just one result. However, the set property would have operated to all of those three propositions, right? So this is how we actually configure a strategy in Pega. There are complex strategies. We can use strategies in the strategy as well that we call sub-strategy. Let me just quickly walk you through to some important shapes. So import data. In here, we have already used import data, import proposition import. We can also import particular customer related data. That could be account information, that could be something else as well. We could also include interaction histories and interaction history summary. So whenever a customer is actually given an offer through the decision strategy or through the campaign or decision NBA, whatever we are using in Customer Decision Hub, Pega automatically produces the interaction history. Each particular offer has an interaction ID and what was the outcome, right? So we can use that data as well as our case might need. In the business rule category, we have decision table, decision tree, map values, split. In the decision analytics, we have adaptive model, predictive model, scorecard model. That's how we actually include models into a Pega strategy. In the enrichment, we already have used set property. There are other stuff related to data join and decision data, which also can be used. Arbitration, we just use prioritization. We could also use filter. Filters are useful when, let's say that we want these offers to be given to the people who are, let's say, above 18 years of age, right? So in that case, we use filters. There are contact policy where we specify, okay, we cannot contact a customer more than twice a week. So that kind of policy is actually set through the contact policy shape. There are segment filter and other stuff. Okay, so these are some key shapes we will be discussing and actually using all of these shapes in detail during the course. So that concludes our demo 1. Demo 2. So the data scientist is, I mean, yeah, it's a great deal to know how strategies are configured, how they work, how they operate, but most of the area of the work for a data scientist would be on the modeling. So how do we create model, how do we manage model, and how do we use a model, right? How do we determine the success of a model? So for this demo purpose, we are just going to create a predictive model quickly, and I will walk you through various aspects of the model creation. So I'm going to just switch to a different user that I've created for the data scientist role. So I'm going to log off from here. We will again be landing on the Customer Decision Hub portal only. And like I said, in the intelligence section, there is a menu or there is a navigation for Prediction Studio. So Prediction Studio is a brand new studio that Pega have now introduced for data scientists, where they can manage, create, delete, import data models related to which can be used into Pega strategies. So these are the models. If you click on the model menu, it will show you all the models which are already created in the system. And now we are going to create one prediction model, predictive model. So there are 4 types of model that Pega supports at the moment. We will be actually covering all of these into the course. So we are going to create a predictive model. Let me quickly brief you between predictive and adaptive model before we create one. So predictive, like the word says, it is a prediction. When we make a prediction, we must have some data to make that prediction, to base that prediction on, right? So here we require history of that particular kind of behavior. Whereas in the adaptive model, like the word says, adopt, learn every day. So we don't really have any kind of data in hand already, any history in hand. We will just be configuring, okay, these are the key parameter where we want to create a model, and we create a model, and later on model keeps evolving. It will keep evolving based on the new results that it sees. So for example, if black label and blue label, we have actually created a model to output black label or blue label, right? So initially it will be 50-50, and later on it will see, okay, black label is being actually opted by very customers a lot, and especially the customer between age group of 20 to 30. So that's how Pega model will keep on learning based on the AI, artificial intelligence. And later on it will see, okay, if any customer comes and which is actually in the age group of 20 to 30, it will prefer black label for that. So this is how adaptive model works. Text categorization and text extraction are the other modeling, where we actually receive certain text and we categorize them into certain categories. Extraction is where we actually extract particular section of the text into a given file or given data set. So let's create a predictive model. Let's name it churn score. So churn basically is when we say that what is the possibility of a customer leaving the company, leaving the services of the company. So that is called churn, right? So we are going to create a model where we will be determining the churn possibility of the customer. So this is about the retention. Whenever we see that we need to retain the customers, then we need to know what are the customers who are more likely to leave, right? So this is a retention issue. And we are going to use template churn modeling. So this is a Pega provided template, OOTB template that we are going to use. Right. Like I said, predictive model actually require data. They require data to learn, they require data to produce the model. So we can actually use a CSV file, we can use database, we can use data flow, we can use data set. We will be covering all of this, but for this demo purpose, we are going to use just the database. There is an external marketing database where external marketing data has a table where all the customer data is available. So churn customers. There are 1,000 records. Let's just quickly walk you through the fields. So there is a customer ID field, state, which state this customer belongs to, what is their phone number, what has been their sentiment so far, negative, positive, what are the internet, do they have an international plan, do they have voice plan, voicemail, number email, and then total day minute, total day calls, right, total day charge, how many calls they have made, how many minutes they have actually spoken on the call, and what has been the charge of that day. So total day, this is how it has been actually updated in the database. Total evening minute, how many evening minute do they use, total evening calls that they do, total evening charges. This is in the same manner we have night charges and night call detail as well, international minutes and charges and call details as well. Number customer service call, how many times the customer has called for the service on the service center. total number of dropped calls, and churn so far. Churn value is actually a binary value, so basically true and false. So this is these are the fields which are available in this database table that we are going to use create a model on. So there are 5,000 records, all have been imported. Now we determine, so like predictions are actually based on certain evidence. Those evidence are actually based on the attributes. Now we categorize the attribute, what category that particular attribute belongs to. So one is categorial, right? Where we say that, okay, this category belongs to, let's say, Indian or someone from US, right? So this is a category, right? The other one is numeric. Is this particular attribute is numeric in nature, not category. It is a numeric in nature. And the other one is not used. Okay, this particular attribute of that customer is not to be used. So customer ID is actually, it could be numeric or it could be alphanumeric, it could be anything, but it cannot determine the behavior of the customer. Customer ID is kind of, unique to all the customer, and it cannot be used as a predictor. So we will say not used. State, yeah, people of the certain state might have certain different preferences based on their geography, right? So here we have state as a category, right? Phone number is actually not a predictor. It could be, I mean, we cannot determine anything about a person based on his or her phone number, right? So let's mark it not used. Sentiment, negative or positive, yeah, that matters. People who have negative sentiments, they might have had issues with the company, right? And they will have a different sense about the company. So this is important, and this is a category matter. Similarly, international plan, the people who have international plan, the people who do not have it, also makes a good candidate for the predictors. Similarly, all these things are important, and because these are numeric, so these have already Pega automatically identifies. A few where Pega might not make a decision properly, we can change them, right? Let's click on the next. Right, so outcome, we are going to predict if the customer is going to leave us or not. Two things, either we can make our prediction yes or no, or we can say, okay, on the scale of 1 to 100, the possibility of leaving this customer is, let's say, 40% or 80%. So if you want to yes or no answer, we can have binary. If you want continuous, that is, okay, on the scale of 1 to 10 or on the scale of 1 to 100, what is the chance? What is the score of that particular? For this demo, we are going to base it on the binary, and we are going to use churn as an output field to predict. Now, if the value of the churn is false, that means the customer is going to stay. The customer is going to be loyal. Whereas if the value of the churn property is true, that means customer is going to be leaving the organization, leaving us, right? Okay, just going back to set a sample size. So once we have determined this, okay, this is very important. So we had total 5,000 records. Now, like we discussed in the predictive modeling, we actually need data to train the model so that the model can actually make better prediction. So we have 5,000 records. Out of that, how many we want to retain and how many we want to test. So let's say that we are going to retain 20% that we will be using for the validation of the model, and 20% of the data we will be using for the testing, and the rest we will be using for the development of the model, right? So 60% will be used. So there were 5,000 data. So 5,000 are going to be used for the validation of the model. 1,000 are going to be used for the testing of the model, and 3,000 are going to be used for the development of the model. All right. binary, and we want churn. This is if the value is true. All right, so as soon as we have actually selected this, this shows that okay, how many cases belongs to development, how many have false, right, and how many have true. Pega automatically does that, and it actually does on the data set which we have used for the development, that is 3000, validation, that is 1000, and test, that is 1000. So this is outcome field value. Outcome category wise as well, same data, same chart, but here we were using just the value, this value, and here we are using category. So basically loyal or charm. We will be discussing all these charts in detail during the course. Now, Pega automatically creates the predictors based on our selection and group them, that we will see on the next page. But here we see that, okay, number of dropped calls is a numeric type of predictor, right? And its bind interval is 8, group interval is 4. We will be discussing these in detail. And performance difference. Okay, so here we say that all the predictors with the performance below, we can specify that, okay, we want everything that is performing better than 80%. That is only what we want to see or we want to apply. We can do that kind of filtering as well, right? So let's just see the number dropped calls, how does it perform. If I click on that, so it will give me the grouping. Okay, so all the people between 0 to 10, so total number of calls dropped was 10. I mean, any customer having the number of call dropped were between 0 to 10. And it has shown us how many % of the cases have 0 to 2. Excuse me. Okay. And in def and in the validation, it is not using the testing. So in the validation data set, that those 1000, it says that, okay, how many %? So it is less than 20%, a little less than, but and this development has a little over 20% cases or the records which have number of dropped call between 0 to 2. What that signifies is something we will be discussing in more detail. But as you see that when the number of calls are actually dropped call are actually in between 7 to 10, this particular line, which actually is indicating churn rate, is going high. So anyone who is going to have lot of dropped call, there is a possibility that they are going to churn, right? Churn rate here, if you see on the scale of 0 to 1 actually, so 0.16, 0.32, right? So it is going very high, 6.5. Okay, so this is how we see how the grouping is going to work on a particular predictor. Based on that, we can actually mark some predictor not to be used. So let's say that state is something that we don't want to use as a predictor, right? So we can simply ignore that. So state will not be used. We can determine each and all, let's say international as well, is also not making much of good prediction, right? So we can actually, if we want to, it actually depends our use case. Ignore that, we can ignore that as well, right? Let's create one more field. So we have a lot of number of minutes, evening minutes, right, night minutes. If we sum them up, okay, how many minutes a person is actually calling, right? If we sum them up, evening, night, and the day, and if we create a predictor on that, right? So we don't really have a field for that to store total number of minutes. We just simply create a virtual field. Let's say total minutes. Okay, and this will be the sum of total day minutes, okay, and then total evening minutes, and then total night minutes. All right, so Yeah, let's validate it. This is fine. So this is how you can create a virtual field as well without creating that particular attribute or the field in the database. But you can just simply create certain virtual field as your use case require. You can assign that. It could be a static value, it could be calculation. You can use functions as well to derive the value for that virtual property, and then you can use that property as a predictor. So let me just, okay, so this is the total minutes. Okay, it is actually its group performance is 71, validation group performance is 67. Let's see how this predictor is working on the grouping part. So if you see here, total number of minutes, it's not a good predictor, even though the people, it's actually giving us a grouping on the really bad data, right? Someone having 5,000 to, 509 to 568 really actually have, we really have a lot of data in that category, right? But the predictor is actually not giving us a clear picture. It says that when number of minutes are less, the person are going to churn. It's very unlikely. So just to show that how we can actually create virtual field and how we can actually make a decision whether to use that particular predictor or not, I just showed you that, and how to analyze that. It says that someone with 490 to 509 minutes have high churn rate, right? And someone having 701 to 876 minutes daily might have even higher. So this graph doesn't show us the clear picture, and number of minutes might not be, either it is actually showing us a pattern that okay, once the number of minutes are increasing, people are likely to churn. That means our plan which we are offering for the higher minute consumption is not very good, and people are likely to. But this is not giving us that picture. But in certain area, this might also give us a picture where we have our plans model in that way that okay, up to 500 minutes, the cost is very high. Whereas if you increase to 500 to let's say 600, the cost goes down, and then again it goes high. In that case, this makes sense, and then we will be using that. So it is always dependent on the use case and your business scenario. At the moment, I'm going to keep that. All right, so let's go to the, click on the next. We have selected all the predictors. Now, Pega automatically creates group for them. We don't really have to worry about. We just need to see if we are going to all the predictors. So for example, if group 1, there are 2 predictors. Group 2, there are 2 predictors. Group 1 has just 1. Group 4 has just 1, right? So it actually has created 12 groups. It's best practice, unless and until you are sure to use best of each group, just one, the best, having best performance, that predictor of that group, particular group, must be used for the modeling. Now there are 3-4 types of model that we create. Regression and decision trees are the most generic one. Regression is where actually we determine one particular property against set of property and we measure the performance. And the decision tree is where we actually determine the modeling or the sampling based on the tree structure. We will be seeing that. So let's click on the decision regression one, how it has been created. So you see here, this is a scorecard model. So even if we go to the total number of minutes, so this is how the weight it has calculated. Someone who are actually using more than 700 minutes will have greater weight. Similarly, number of dropped call, you will see that 7 to 10. We saw that on the previous screens, right? The people with 7 to 10 drop call are highly going to leave that, very likely that they are going to churn, right? Similarly, in the decision tree model, see, everything 100% is coming into probability of 0.14, and then it actually on the tree basis it determined okay, 0 to 7 will have this much probability and the size from the sample is this much. So this is how the tree model works. We will be discussing that in detail during the course. Now we can actually analyze their charts as well. Let's select all of these, I mean both models, and see how they perform. Behavior, lift gain, these are created by Pega automatically. Discrimination is something that we need to look at, okay, very carefully. So this line in the orange is actually for the decision, and regression is the blue line. There is one term called AUC, area under the chart, that actually determines the performance of the model. So if you see here, this is churn percentage loyal, right? So for the lowest level churn percentage, this blue line regression model is performing better than this. But as it increased, the loyalty or the percentage of the cases increase, the decision model takes over, outperforms. But this is a very minor difference, right? Sometimes because we are using sample data, and it's mostly, you know, actually it has it is distributed uniquely, right? So that's why we are actually not able to see much difference, but in the real life you will see a great difference. But if you see here, somewhere at 22.2 and 90.87, these are actually performing same, but as the case increase, the decision tree is actually taking outperforming the regression tree. We will be discussing that in detail during the course, and we will be coming back to this particular chart once again in the demo. So let me just go back, and let's see the score distribution. Right. So Pega, whatever sample size we have taken, Pega automatically distribute them into 10 data sets, and it actually maps the dev, the testing, and the validation part, and the percentage of the cases. Okay. We can see that for the decision tree as well. Right. Okay. Now class comparison. So those grouping, those 10 grouping are actually nothing but the classes that Pega actually derived them or distributes them. So the same chart here on again on the analysis. So you, after analysis of this, you might decide, okay, what chart, what particular model am I going to use? So if you see overall, once the loyal percentage are increasing, this particular decision tree model is outperforming the regression model. So we can select any of these two. So let's select decision. Now we specify in which particular class we are going to save that customer data. In the manage, we can import the model, save it to a file, or import as a PDF as well. Let's click on the finish. So this was the model we were building. We got an error. If you by any chance cannot complete that model, you can always come to the models. You will see what is the status of that, and then you can start it from here. So this model seems to be having problem with. So just to show that last step, I will just use another model. Okay. So once you click on that, you will be taken out to this screen. You can update that model as well. I will leave everything as it is. Just go to that last part. All right. So after that, you will be taken to this mapping screen. So whatever field that model has used, you'll have to map it to the class where you are saving it, right? So international plan, if there is any property for that, yeah, there is. So you have to simply map those. So total day minutes, and then total evening minutes, total night charges, then number of drop call. Once you have done it, you can save it, and then you are free to use it in any strategy. So that concludes the predictive model demo. If you have any questions, please do ask out. All right. Thank you very much for this. And that actually concludes the demo.